you might also discover something new. Let's start. I have opened Excalibur, and we need to describe functional requirements for sure. Identify clients. You can identify them by IP if they are anonymous, also by ID if our users are authenticated, and this will be the rate limiter, of course server-side rate limiter. For social media, we will not do the strict one for payments and something like that. And also your users might be even a public API, like Google API, something like this. So your key may be just like the API key, and also your internal services might be the key for this. For like can be service account. The next requirement is returning of proper headers, HTTP headers, and a status code. We know that it is 429, too many requests. And of course, our rate limiter must rate limit by configurable rules. What's the scale? The default answer would be here like 100 million daily active users and 1 million requests per second. I think that's fine, and we can proceed to non-functional requirements. If you forget about non-functional requirements, like what characteristics, you can use the acronym scale for clouds. I don't remember each letter of this, but S stands for scalability, and then CAP theorem. It's partition tolerance, where you choose either consistency or availability. Also latency, then goes environmental conditions. For example, maybe your clients have poor internet connection and something like this. Then fault tolerance, and C, I don't remember what does it stand for, but our non-functional requirements, sorry, I digressed. Our non-functional requirements will be, first one is availability. Yeah, we choose it over consistency, because it is social media. We are fine when we might have a burst of requests. If a user is allowed to make 100 requests, it can do 105 because it's fine. Or also, if a new rule added, it can be not immediate. We tolerate the latency. So availability over consistency. The next one is let's talk that. Yeah, let's mention latency. It should be low, but we need to quantify this. Low latency of rate limit check, less than 10, let it be 10 milliseconds. Fine, and scalability to 1 million requests per second, of course. Let's transition to core entities. Your core entities, if you forgot and don't know what core entities, you can check your functional requirements, and they will be a tip for you. You will just see that it should be request. Also, it will be our rules. Yeah. Maybe rules will be stored. Yeah, it will be stored like map, like a hash map. Yeah. And also, what else? Request, rules, and of course our client. Our core entities are defined. In regular system design interviews, you will need to choose a protocol, HTTP, gRPC, or GraphQL, and you will type the roles, how they look like, what they return, their URL. Like you will type get, post, and this URL request, and what's in the body or headers, because usually we store our user in headers, GPT token, and so on. But here we have rate limiter system design, so we are fine with just a system interface that will be a function that like it will look like this: is request allowed. Yeah, oops. Come on. Oh, okay, fine. Is request allowed? It will receive in arguments our client ID and row ID, for sure, row ID, and returns pass boolean, true or false. Also remaining tokens. It will be integer. And most likely last refill time, it can be milliseconds, like I guess integer or timestamp. So approximately like this. And you might ask your interviewer if it's fine, if you can proceed to the next stage. Maybe you forgot something. Any tips are welcome from the interviewer. Right, I think we can proceed to the interesting part where we start with small things like designing high level API design, and then we can dive deep into details. And we have to satisfy our functional and non-functional requirements that we described here. We will have, okay, I will start. We will have, come on, client. We should ask a question: where will be our rate limiter in this architecture? Yeah. Where will it reside? So we have a client, and usually there is an API gateway and microservices if it is a social media. So it will have various microservices like responsible for creating posts, accounts, and like likes, retweets, maybe something like this. Okay. So let me unite them with errors. Oh, okay. Errors. And the last one. Our rate limiter can be in microservices, but it is not recommended. Hold on. Oh, right. Rate limiter. It will be blue. Not only text, this. So it can be, one moment, small text, and like this. Yeah, it can be inside microservices, but it is not recommended because it will be fine-grained, and each microservice will have own rules. And what if the request comes to different microservices and there will be no unified place? So people also put it as a separate instance, and microservices will have to make an additional network request here. It's maybe additional 2 milliseconds or even more, and we might not satisfy our 10 milliseconds non-functional requirement. Right, and usually people put it, if it is a small application, so it can be fine to have a gateway to manage rate limiting. But when we want to scale in, and there will be multiple gateways, because it will not be our single point of failure, we will have a Redis instance. Like this. So there will be a consistent pool of TCP connections managed by our gateway. You will have an SDK where you tune your pool appropriately. So that's it. Our Redis that will contain keys like Alice, bucket, and there will be a hash map containing like such values like token, like 50 and last refill milliseconds or time, and there will be something like this. Right. If we talk about rules, yeah, we need to mention rules. You can hard code them like statically be situated in gateway, but you will have to redeploy the gateway each time you add a new rule, and it will be a cost of maintenance, and we have a downtime. So you should a popular approach here would be a separate instance. Yeah, you will have a separate instance where you will install etcd, and a persistent TCP connection will be established with our gateways. And when a new rule comes, etcd will like push it, and gateways are subscribed to these changes, and yeah, it will watch changes of rules. And finally, it will update in-app memory rules cache inside the gateway. Yeah, as I said, it will look something like it can be really a map, just like map, string, and rule. In-app memory cache. So I think that's amazing approach to do this. And if we have multiple gateways, they will be all subscribed to this instance with etcd, and that's amazing. Let's describe our flow. Request comes, gateway fetches token and last time refill from Redis with like this. Maybe there will be a prefix like this, and user 123, and you get because we use hash many gets, so you take tokens and last refill time. Then in your gateway you calculate the tokens based on last refill time. And I want to mention that there are 4 types of rate limit known to me. First one is fixed window counter. It uses hash map, and it is not efficient because imagine our user makes 100 requests and exhausts its limit, and he makes it first several seconds, and imagine our window is 1 minute, so the user will have to wait for next 50 seconds and just do nothing, and it is not good for availability. So the second one, sliding window lock. It usually uses the heap data structure, and it consumes lots of memory, so if you are rich in it, you can choose it. But because you have to store like each timestamp, and it will take a lot of memory. For example, maybe if you have 10,000 users, it can take up to 8 gigabytes of memory, and it's not recommended. Usually people choose sliding window counter. It is also pretty accurate for rate limiting, and it's if you use Go, it uses something like struct last, and there are 2 values usually, but also maybe window start, something like that. So there will be last window count, for example, it will be integer, yeah, and current window count. It is more efficient in memory than, like, it's only 16 bytes, and also maybe some kind of timestamp when the window started. Yeah, and I would take token bucket. It stores tokens, last refill time, and you can Google about this token bucket and other types of rate limit and watch the videos about this to make it clear. Basically, each second, for example, each second a new token is added to the bucket, and we recalculate it when we receive this. When the request comes, it is recalculated in air, and it returns into our data flow. As I said, like, request comes, gateway fetches token, calculates the tokens based on the last refill time, returns pass or fail based on if tokens more than 0, and update status of bucket in Redis. So that's it. Yeah. I also want to recheck our non-functional requirements. I believe that functional requirements. We talked about rules and identify clients. It's fine. Regarding returning of the status code. It will be 429. And as for headers, they will be something like this, like x rate limit, and like 200. And you should also check, I have prepared somewhere in notes. Let me show you, just you will not wait. Retry something, yeah. Something like this. You will have such headers. We satisfied functional requirements overall, but what about scaling? Yeah, if we check non-functional requirements, we have scalability, and let's assume that our Redis instance can process 50k operations per second, maybe 100k, but we see in our data flow that we also update backend status. We not only fetch but also update, so there's like 2 requests in one, unless we have the Lua script, which I will mention later. So 1 million divided 50k equals 20 instances. You can, yeah, you just have 20 instances plus 5 for redundancy, for example. I believe that there will be less than 10 milliseconds. Yeah, this is the stage where we should go to the deep dive, because functional and non-functional requirements are satisfied, and that's all right. And interviewer might ask you advanced questions, or you should dive into your design and talk about maybe your places where you want to improve. So maybe your, yeah. I want to remember the phrase, but okay, I try to remember the phrase. There is no ideal design. Trade-offs. Oh, okay. You talk about trade-offs. Oh, silly. And your interviewer might ask you what will happen if Redis fails. It is dead. And usually there are 2 approaches, like fail close. It's good for strict like payments applications. You do not accept requests at all. Or fail open. It's for our social media, social feeds, social media. We are fine to receive requests if rate limiter is dead. Also, we can touch the question of concurrency, because it's Redis. It cannot do like Postgres atomically and transactions. So concurrency here is a relative topic. And a nice answer would be introducing a Lua script that will fetch the tokens and last refill time and update them and return just remaining tokens and last refill time. So it will add atomicity to our lookups from gateway. So Lua script can be mentioned. Also to satisfy our to satisfy also our reliability, yeah, there will be Redis replica, and it will be replicated asynchronously. So if one Redis instance is gone, we are fine if Redis replica replaces it and it will have not sufficient data, something is lost. We are fine with this because we are not for consistency, just availability. What about sharding? You would use consistent hashing sharding here. It's like a ring, imagine a ring, and shard number 1, number 2, 3, 4, and if we add fifth shard, it will help other keys to migrate only from the fourth shard, but other keys will be not touched. In reality, you will have a Redis cluster. It will manage sharding for us. And that's amazing. You just have a consistent pool of TCP connections and tune your pool. And that's it. Also on the interview you might talk about you place your replicas geographically close to users. If it is a payment application, you will likely have a global Redis cluster and that's it. That will and the trade-off will be the latency, but we will have a strict rate limiter. But for our case, when it is a social media, it's fine to have inconsistencies. Maybe we will have regional clusters and configure them, but yeah, we are fine if a user makes a request and to the US region and then to European Union region, and there will be 2 counters, but we are I guess we are fine with that, with this. Also, I might forget something. Let me check my notes. Maybe all right, we need to think also about TTL in our Redis. You know that 2 most difficult things in programming are, first one is naming variables and functions, and the second is configuration of eviction policies of cache, like TTL and so on, like list recently used, and you need also a strategy for this. So TTL, it will be like you configure something like this, like expire, user 1 hour. Also, we can also, in real life, we can have a fallback rate limiter. Like if the main one dies, we can have also a rate limiter within the gateway in its in-app memory cache. There will be something like sliding window counter, and our application will continue to work. Or it is worth mentioning about hotkeys. Really important question. Imagine we have popular public API like Google. We have the client that makes a lot of requests, like 50k requests per second. So let me zoom in. Regular users just do like one request and one Redis lookup, I guess so. But when it's like popular user, our application will identify that, and we will use a hierarchical rate limiter, or it is called like lease, something like this. Yeah. Yes, it will be leasing. So our gateway leases, let's imagine like 400 requests per second, and it will store it in app memory. So our popular user will go to gateway, and when 100 requests are drained, gateway goes to Redis. Only like for next portion of, there will be like, if you have 10,000 tokens in Redis, gateway will take 100, and there will be 9,900. So you might understood the logic. Let's not stay on this topic. We have a limited time that we can go to advanced topics, and it can take a lot of time, and the more you know, the more you can talk about these things, even on a simple topic and simple system design like rate limiter.